It has come to my attention that some APSI consultants have been advising their teacher participants to buy these cars and launchers from Dollar Tree to do an activity related to conservation of energy, which is great and all, right? No biggie there. But what I want to do is I want to talk to you a little bit about how I use it. And then more importantly, how do you fix them when they break? So we just did an activity with these little cars and launchers. And let me just show you right here. This is how many of the launchers actually broke across 2 class periods of AP Physics 1. So it's pretty important that you know how to fix them, or else you're going to be really sad when you paid $1.25 for each of these little cars and launchers, and then half of them don't make it through the first period for you. First of all, let's talk really quickly about how they work. There's a spring-loaded mechanism inside this little, cylindrical piece right here, and then you back the car onto the cylindrical piece right there, and then it latches into place. And then when you push the button, then the car snaps off right like that, right? So what I have my students do is I say, okay, I want you to make measurements in order to figure out the spring constant of the spring. And so we know that the spring starts. So basically, I expect students to start with, 1/2 kx squared energy, and then say that once the spring is let loose, that becomes 1/2 mv squared energy, right? And so if they can just figure out the launch speed, that's the tricky part, the mass, that's a scale, and the spring's compression, which just requires maybe a ruler or something, right, to just measure this, because this pretty much goes all the way back in, right? So that, I call that the spring's compression. Then you can get the spring cost, right? Well, the tricky part is getting this launch speed, right? Well, what are some things you could do? You could lay a meter stick or two out and then time how long it takes the car to go past 1 or 2 meter sticks. 1 meter stick, these things do go pretty fast, but they also have a ton of friction, right? So you can't put too many more than 2 meter sticks or else the car can't really go that far, right? Velocity equals delta position over delta time, maybe delta distance over delta time is what I'll call it, right? Another way to do it is to let the car go until it stops. And so the V initial is the launch speed, the initial speed after it's launched, and the V final is 0. It's conceivable and actually quite practical to measure this distance that the car goes and the time it takes from the launch time until it stops, and then say velocity equals distance over time. But warning, it turns out that this is the average velocity of this entire stopping experience, right? That is not the initial velocity, and students need to be trained on this, especially if you're starting energy in, say, the second semester like I am, right? So then what we say is well, really, average velocity is the initial plus the final over 2. Well, the final velocity, if you let it go all the way to stopping, is 0. So then if you cross multiply, the initial velocity is really twice distance over time. And again, this is assuming a uniform constant deceleration, which for these cars is actually asking a lot. And that's because what the car will do is it'll go in a straight line for a little bit and then kind of spin around like that. So it has low friction until it does this, then it has a very high friction. So another option that may be available to you if you're willing to explore it is to lay out a meter stick or 2 and have students take a video and then try to get, the delta distance is 1 meter and the delta time is a very short amount of time measured between 2 frames of the video, and then maybe assume that friction has not slowed it down very much. Okay, so once you get the speed and you have a scale and you have a little ruler, you can get the spring constant. It's on the order of about 100 newtons per meter for these little things. Okay, great. What a great little activity. How do you use it, Friendly? 15-minute warm-up or 15-minute end of class type activity, one of those bookend type activities, right? But the problem is that the blasted little things break all the time. And I don't want you to be sad that you got this, even though it's $1.50, you get 20 of them, one for each student or one for each pair, maybe 15 then. That's whatever 15 times 5 quarters is. That's $17.50, I think. Anyway, so that being said, let's talk about how you're going to fix it. So what you're going to do is when you go to Dollar Tree, you're going to get a bunch of these, but you're going to get one of these Phillips head screwdriver things too. Very small Phillips head screwdriver. It's not really small. It's not like glass that's fixing or anything like that, but it's small, And then what you're going to do is you're going to, what does you mean by break, Friendly? Well, the little pushing nub thing like here, it actually exerts force because the spring is in place, but this one is not exerting any force, and we can't give this a blue pill. We can't fix it that way. We got to take a little screwdriver, and I'm going to try and make sure you can see this, okay? So I'm unscrewing this here screw right here, Sorry, I'm keeping my eye on the video while I'm unscrewing, so hopefully you can see what it is I'm doing here, okay? So we're going to unscrew this sucker right here. And really, once you become familiar with the insides of these, they're very easy to fix. In fact, what I do is I have about, however many I need. Maybe I need for 30 students, maybe I need 15, but really I have maybe 60 or 70% on standby. So that'd be a total of 25. So I have 10 of them on standby. And then when a student breaks, sarcasm quotes, breaks one of these, then what I'm going to do is I'm going to have them swap it out for a new one, right? So you see the spring came out of place. It's just lying here, chilling and thinking he ain't got no job. And I'm really going to take the whole thing apart so you can see me as I put it back together. Now, they come in different colors. That's the outside plastic, comes in different colors, but the inside plastic pieces are all black, okay, just like a real person, right? And so they may be a little bit difficult to see. So there's this piece right here, which is part of the latching mechanism that latches the car on. And if you look carefully, that has these two little cylinder pieces, and that settles in right there. Do you see where that's going to go? That settles in right there. Remember, if you can put it together from base pieces, then you can do this, right? Okay, now what we have here is we have the part that's shaped like an airplane fuselage. Yeah, that's what it's shaped like for sure. Okay, and that is going to go into here, into this piece right here. So this piece right here has a flat end, okay, and then it has this kind of square end right there. So you place this into the square end, okay, everybody watching like that? And so that's the thrusting part. That's the part that thrusts out at the little car right from behind. Okay, and then what we're going to do is we're going to put the spring. This is the part that comes out so easily, is the spring just settling into there. The spring just settles into there, right? Now, these two pieces right here settle directly into these two kind of holders. So watch as I put it in. There we go. I'm going to settle it in. But now watch what's happening with the spring. The spring is kept in by this piece right there. Do you see that? So I'm going to push it in, right? I'm not going to use too much force, but it's just going to settle in really nice like, okay? So then we see that the back end of the spring, but you see it's even still trying to get out. You see that? It's going to come out, right? So just expect that it's going to come out, right? Now, I don't know if you can see these two little pieces right there and right there, but that is what the button actually pushes down on. So that's the button, and these two pieces push down on these two, and that's what releases the little latch. So we're just going to set that just nicely on top of there. It doesn't slide into anything. It just rests right there. And then as we put on, we got to make these two things line up with these two. And then this last one lines up here. It's not that difficult to do. Just be very careful as you do it. If you feel any resistance, then kind of move around. And then see the button just fits right in place. So now what am I going to do? I'm now going to put the screws back in. I'm going to screw it back in. And again, with a little practice, you can be fixing these up while the students are still just doing their activity. So you might have half them break during a class period. You have another half, an extra 50% that you can swap out with students, right? And then you're just sitting there and you're fixing them, right? So there you go. See, now it works just good as new. So I want to make sure you saw that because these are really cool. And they give students an excuse to play with toys. And for me, especially second semester physics, but also first semester as much as possible. But really in the second, we're wanting to play with toys, especially once we learn energy. All right. Give me a holler if you would like. Let me give you my website really quick. It's fine-physics.com. There's a contact there. Just reach out to me if you have any questions or if you have any other things you want me to post videos about. And then you can also see here professional development opportunities that I offer to physics teachers and in the near future to math teachers also. All right. I hope to hear from you soon.